Hello everyone, I am Gagana Premnath. I am presenting my poster Integration of HPCC Systems Terraform CI with GitHub Actions today and the guidance of my mentor Godji and Ming. To understand what my project really is about, currently we are deploying HPCC systems using the 4 main Terraform modules manually. So in order to overcome manual efforts, we are deploying this automatically by creating CI/CD pipelines using GitHub Actions. So the 4 main modules that are required as a part of this deployment are VNet module that manages the virtual networks for the environment, the storage module that sets up the necessary cloud storage, and the AKS module that deploys the AKS cluster to host the HPCC systems, and the HPCC module itself that deploys the platform. Next, how do we achieve this deployment of these 4 modules? So for that, we need prerequisite tools and some process or task before we do this automatic deployment. For that, we need the GitHub itself, which will contain the Terraform modules that you will be deploying, and the Terraform, kubectl, Helm, and Azure. You need Azure because you are deploying this to the Azure cloud. So when you use Azure, you have to make a login to Azure from the GitHub action file. So to do this securely, we are using an OpenID connect method by creating and registering the application within the Microsoft Entra and with the service principal. These service principals are the secrets or credentials that you will utilize to log in to Azure portal from your GitHub actions. And you save these credentials, the service principals, as secrets in GitHub repository and utilize them in the workflow file whenever you need to make a login to the Azure portal. So the next prerequisite is creation of storage accounts and the storage containers for each of these modules manually. So these storage containers will host the config blob files, the TFR files, and the state files. The state files are utilized for maintaining the state across the modules deployments so that the data is preserved, and when you roll back, you still have the data. You can have an option to roll back as well. So this is for the state file, and the storage account will have, you have to manually move from each of these modules, you'll have to manually move the Terraform variable files into their respective containers so that once the deployment starts, the data is copied from the storage containers to the local, utilized that, and then again updated the storage data using a AZ copy command within the GitHub action files. All this data storage happens in the containers because you can utilize them when you need them. For example, you start the process with all these prerequisites. Now you go ahead with all the 4 modules, the VNet, storage, AKS, and HPCC in order. So once the VNet is deployed, you will have the VNet names created, virtual resources created, and that is utilized in the storage module. So what the deployment action files does is they go and see the containers of the VNet to access the data or resources created as part of that module within, and use that resources as required in the storage module. So each module deployment is dependent on each other, and you have to have the data preserved between them and the state is preserved between them using the state files. And this changes happens, or this deployment happens when you push or make change in the repository, and this is how the result looks. The result is all the tasks that I have shown or I have spoken so far is written as steps in the workflow file, and these workflows are executed once the deployment happens and the CI/CD pipeline is triggered, and you can see the success and failure, and then if there is a failure you can debug and come back to it and rerun the job or the step that is failed. This is a snapshot of the AKS container hosting or containing the config blob files and the TFR files, and this is the config blob file that contains the AKS data, which is in the JSON format. Once your all 4 modules are deployed, you will get an ECL watch URL that you can access in the browser using the URL and on a known public IP. And the future enhancements could be to automate the creation of manually the storage containers and uploading the TFR files, and also to utilize the GitHub runners instead of self-hosted runners that we are currently using. And to conclude, the main agenda was to automate the deployment of Terraform modules, and it has been achieved to an 80% automation. And enhancement could be to make an 100% automation with so that efficiently you can manage the infrastructure on the cloud platform. Thank you.